In this tutorial, we are going to talk about various criteria that will help us explain whether two triangles are congruent or not, okay? And the very first one we are going to talk about is what is known as SSS criteria, okay? Triple S in short. Now, the reason we are saying triple S, each S refers to a side. And we know that the building blocks of a triangle are sides and angles. So in this case, we are going to measure all the sides of two triangles, and hence it is called SSS as the criteria of explaining the congruency. All right. Okay, so let us take a look at these two diagrams. I have triangle A, B, and C, and then I have triangle D, E, and F. We are going to find the corresponding side of these two triangles and will establish whether they are same or not. Okay. So as I look into my first side, AB, it is 5.5 centimeter. By the way, these dimensions are not to scale. It is here only to help us understand the concept, okay? So let us get back to the point. The side AB, 5.5 centimeter, I'm going to find a corresponding side in the second triangle, and that is side DE. So I find these two dimensions are the same, and these two sides I will say as corresponding. The second side is 6 centimeter. It is the side AC, correct? So it is 6 centimeter, and I also have an equivalent side in the second triangle, and that is DF. And the last one is side BC of triangle 1, 9.1 centimeter, and I find an equivalent side here as well. So we have all three sides matching, and therefore we will say that these two triangles, triangle 1 and triangle 2, they are congruent. And as I'm using this symbol tilde with two lines underneath, this symbol really means that two shapes are identical to each other or not. Now my second pair of triangle is, let's label that as triangle PQR, and I have triangle X, Y, and Z, triangle 3 and triangle 4. Now here we are going to define another criteria of congruency of triangles is that it is known as SAS, meaning side, angle, side. But this angle has to be an included angle between the two adjacent sides, okay? Let's say we get rid of this dimension, which is PR in the triangle 1, and we also get rid of this dimension, which is XZ in the second triangle, okay? Where I'm going with this is that if I start from point R, because it has a fixed dimension 6 centimeter, I will draw this line segment 6 centimeter, then I will create an angle of 50 degree, and then I will move 7 centimeter along this direction, and I will stop at this point P. Okay, meaning I started from point R, which is fixed now, and I stopped here. Now we have these two as fixed points, and exactly same condition will exist here, right? There is a fixed start point, goes in some direction, goes again in some direction at the same angle, which is the angle Q. That means we also have a defined endpoint. And since our movements have been exactly the same in both cases at the same angle, the starting point and ending point have to be at the same distance from each other, right? So if you draw a line connecting the point P and point R, it has to be the same as the point X and point Z, the distance between these 2 points. And hence we say that all three segments will be of the same length, as long as we have two sides and one angle the same between two triangles. Or in other words, we just proved through our discussion that SAS is essentially equal to SS and S. It is just another way of defining these two triangles, right? Hence we say that when you have SAS criteria, meaning two sides and an included angle between those two triangles are equal, we can say with confidence that those two triangles will be congruent, or represented like this. Triangle 3 is congruent to triangle 4. Now consider another scenario in which we are given two triangles PQR and the triangle ABC. In this, one of the dimension and two angles between those two triangles are same. Okay, that gives us a clue to the third criteria that if we define angle, angle and side between two triangles to be the same, then this will define that those two triangles will be congruent triangles. Now, given the fact that we have two angles in a triangle, we can always compute the third angle, which will be the differential from 180 degree, right? So 110 plus 35 is 145. That means the remaining angle in PQR will be at 35 degree. And so will be the remaining angle in triangle ABC, simply because both of these angles are same, identical. Okay. Now let us look at the case that there is the line segment QR fixed, right? It is 3 centimeter. And from 3 centimeter line, from the one end Q, you stretch a line in the direction at 110 degree. It will look like a ray going somewhere, correct? And at the same time, you stretch a line from point R at 35 degree angle from the base, right? Now, this will also go in some direction, right? And the direction will happen to be 35 degree. So both of these rays, they will meet at a point which will be the point of intersection, correct? And we do the same exercise for triangle ABC. Now keep in mind that the base BC is exactly the same as the base QR, and we are stretching those rays at the same angles, both ways, right? And when we stretch rays at the same angle they will meet at a point A, and the distance of point A from either B or distance of point A from point C will be the same as distance from PR or distance from P to Q. So this shows to us that when you are given a triangle in which you have meaning two angles and one side is the same as the other triangle, then we can say that triangle PQR, or triangle number 5 in this case, is congruent to triangle ABC, which is triangle number 6 here. So with this, if we were to summarize our discussion today, we can say that the congruency between triangles can be defined by one of these criteria, either triple S criteria, meaning all three sides have to be the same, or if you are given two sides and included angle between them, or you are given two angles and one side. If all these dimensions are given, you can claim those triangles to be congruent to each other. Okay. With that, we will stop here, and in our next tutorial, we will talk about the similarity of triangles.